Hello guys, let's continue our development of our end language. So in these sessions we will treat functions, but before that we need to update our approach on how to compile source codes. So in next session, in the future, we can treat functions. So for the first concept, I need to treat call frames. So as you see here guys, we have a sample code, we have a top level code or the script, and I have print2, and I have a function definition, and it will just say hello world, and then we have a function call. So in our new approach we will treat everything as functions. So this top level code is a function that includes another function's definition, like say hello. And as you see here guys, we will update this approach. Our VM will treat everything like frames. So for the first frame, and here we have our first frame is the top level code, and our VM will read the chunk of that top level code. It's a function, and it will access its chunk, and when it executes chunk by bytecode by bytecode, it will seize a function call, then it will initialize another frame so it can execute the second function. So as you see here, we have in our frame call, we have a function object and an IP to track the bytecode that the VM executes, and we have a variable called slots, and I will explain what that slots for. So when the say hello function is finished executing, we need to pop this frame and continue executing the first frame, the top level code. So as you see here guys, we need to update our code just to support calls frames, and as you see here we have a stack of calls. The first stack is the top level code, and the second one is the second function, and so on. Every frame it has an object called function and an IP and slots, and objects it has chunks and other things. The idea is simple. When the function is finished execution, we need to pop its frame and continue executing the frame below. So why we need the variable slots? So the variable slots is just points to the stack where the function object exists. So as you see here, this is a frame, the function 2, and this is a frame. As you see here, the slot it points on this function, or in the function number 1 it will point on this. And why I need that? Because I need something called relative indexes. So when a local variable called, I need to access the variable, the local variable, from here, not from the top of the stack. Let's say that we have a function that has a local variable with ID 1. So I need to read the first slot from stack, but not from the start, but from the function call. This is why, because I need a window on the function, and this will help us to relative indexes. So when I need some value, I need to point it from a relative source. So in that case it's a function. If the value is at position 1, I will say slot 1 or slot 2, not from the absolute indexes. So guys, let's jump to code and change our approach. So first of all, I will go to our object another type called object function. So then I will add a type called object function, and it has, as usual, our header object and also a function. It has a name, so it's object string name, and arity. The arity is the number of parameters, and also each object has a chunk to store its code. So that's it. So we add that because each function, it has its own code. So as you see here, our function, it has its own code, and the top level code also, it has its own code, and so on. So let's add these two macros, define as function from value, and we'll do function and as object value, and that's it. And also I need to another macro to check if the value is a function object or not. Is object type value object function, and that's it. So let's add a function that create an object function. Let's return a object function called new function. So let's go and implement that. So then object.c, and let's add the implementation of our function. So what I need to do is to allocate function object function and for the name it's null, and for its arity is 0, and we need to init its chunk, and finally we will return that object. So far so good. So let's go to our VM. So in the VM I will add a macro called framesMax. So our called frames, it has a frame max, so it will help us to identify if we have a stack overflow. So we have a call stacks that have a maximum, so I need also to update the stack max size by multiplying that with frames max. And also what I need to do is to add a structure called we need that because we want to access the chunk of that object. As you see here, we have a object function that has a chunk, and that's what the VM needs to execute the bytecode. Also, we need bytes, IP, and slots. So let's go and add IP also as we'll add the slots. So now I will remove the chunk and the IP, and I will add call frame, and I will add a stack of frames with a maximum frame max, and also I need to track the count of the frame. Okay, so let's go to VM. First of all, we need to go to the VM initializer, and I need to remove any chunk because we don't have that, and also we don't have that. So I need to initialize the frame count to be 0. Okay. Okay, I need to update the runtime error function. So what I need to do is to call frame. I will take frame from the frame count minus 1, and what I need to do is to update this instruction variable because we don't have the IP on the VM directly, we have it on the frame call. So what I need to do is to do frame IP also as frame function and chunk.code minus 1. That's good. And also let's change that. Frame function and chunk. So let's go to the interpret result function, the run function. So we need to update these macros. For the read byte, I need to first of all get the current frame by doing that, frames from the frame count minus 1, and what I need to do is to do frame, and I get its IP, and for read chart I need to do that, frame IP, also here frame IP. For that also I need to call the object function, not frame function, and I need to get that chunks. Okay, so let's go to here for disassembling the instruction. So what I need to do is to get that chunk from who, from VM, from frame function and chunk, also here frame, and I get the IP, and also here frame function and So let's go to the chunk up get local. So what I need to do here is I will not read from VM at the starting from the top of the stack, but I need to read the local variable from the relative indexes by accessing the slots. So what I need to do is doing frame slots. Also for setting local variable, what I need to do is frame slots Okay, so let's go to jump force and update that. We are on the frame IP. Okay, for upjump also frame IP, and also for uploop frame IP. So let's continue and let's update function interpret. In the function interpret we will update that by, we will assume that our compiler return a function based on some source code, and we test that if the function is null, so something must be wrong. What I need to do is to return interpret compile time error, and if it is good, I will initialize our frame call and get the first frame, because the first function we need to execute is the top level function. So what I need to do is to get that by doing VM frame count to 0, 1, and then I will add 1 to that one, to the frame count. So frame function will be function, and frame IP will be function chunk code. And for frame slots, so for the first sum it will be VM stack, and to execute that function we need to push that on the stack as an object function, and we interpret the result by calling the function run, and finally we free the VM and return the result. So that's for the VM. So now we need to go to our compiler to update our compiler, because our compiler, he needs to return to us a function object. First of all, let's go to vim compiler.h and let's update the signature of our compile. He will return an object function, and only it will accept the source code. So I need to remove that and include objects.h. So let's come back to compiler.c and let's go to compiler, what we need to add, we will add compiler, we will add a pointer to each function has its enclosing. So I need, for each compiler, I need to add its enclosing. So for example, this top level code, this function object, it has an enclosing. Its enclosing is the top level code. So the compiler of the say hello function is not like the compiler of top level code. So I need to track each compiler what's its enclosing. So let's come back, and also I need to track the function type. Also I need to handle the code of the current function. So remember guys, in the session of treating functions, I will treat everything on the code as a function. The top level code also, it's a function. The whole script is a function. The declaration function is a function, and so on. So I need to fill the chunk of every function. So let's declare that type, and the type is an enum, type def enum, and we will have two types for now. Type is a script for the top level code, and type function just for now. So also what I need to update is the get current chunk. So the get current chunk is a function that will return our current chunk. So let's assume that we are compiling a function. What I need to do is to return the chunk of that one, of this function. If I am on top level code, I need to return the chunk of that top level code. So what I need to do is to return address of current compiler function and its chunk. So remember guys, in this session we will not treat the declaration of function and calls. We just change our core of our end language. We change our strategy to how we treat the source code. So I need to now to add another function that init our current compiler, because remember we changed that structure. So I need to initialize the current compiler by its closing, and for example the top level code, its enclosing, it's null because the script it has not a enclosing, and so on. So let's do that. So let's add a function that initializes a compiler passed as a parameter, and also by its type. So the compiler passed as a parameter, it's enclosing, it's the current compiler, and for type is the type passed as an argument, and also we will initialize the current scope to be 0, and for function we will use our new function that we developed. So if the type is just, it's the top level code. What we need to do, we need to add the function name. If our type is not the top level code, so we are in a function, so we need to add the name of that function to the object function. So what we need to do is to just use the copy string function on the previous token. So if it is a top level code, so the compiler function name is just a null. Also, what we need to add is to, for local count 0, and finally what we need to do is to change the current compiler to be the compiler passed as an argument. So as you guessed it, if we have init compiler, we need a function that end that compiler. So when we end the compiler, we need to return its function object. I will emit two things, op_nil, and emit another byte op_return. So by doing that, I am assuming that every function that doesn't return anything, it will return by default a nil, and after nil we have an operator to halt the machine on that chunk, on the current chunk. So in that case, this function, say hello, it doesn't return anything. So when I will end our compiler and finishing our parsing on that chunk, we need to return a nil and halt the machine on that function. Also, for the top level code is a function, as I said. The top level code or the script is a function. So when we end the top level code, I need to return nil and also the bytecode return to halt the machine. So let's come back. So what I need to do is to read the object function from the current compiler function, and if parser doesn't have any error, I will disassemble the code. If we don't have any parsing error, I will disassemble the code. Chunk, and if the name is null, we will just print script, and otherwise I will print the name of that functions, just to distinguish between the bytecode generated, to distinguish between the bytecode of a function and the bytecode of a script, a top level code. So finally I will return to the current compiler to be the current compiler equals. Why that? Because when I am on the top level code, I will parse this instruction, and when I am parsing a function, I need to change our compiler and and fill its chunk, and when we end the parsing of that function, I need to return back to the enclosing compiler to continue parsing this one. So, and finally I will return that function object. So that's it for now. Oh, I had that init function before, so let's just remove it. So let's remove that one. So let's update our compile function to return a object function, and it accepts as a parameter only the source code. We init our scanner, and we advance with that and that. We have the compiler, we'll init that and pass as parameter type script, because the first function we treat is the top level code. Type script, and we will delete the emit return to hold the machine, and also that and that. And what I need to do is to end the compiler. And if the parser had error, we'll return null, otherwise we'll return a function. So far so good. So let's go to VM object today, let's see, and I will add a case for object function, and let's print function. So we'll use the macro as function, and I will pass value. And also I will break. So let's implement that print function. So static print function, and it will accept object function, and if function name is null, so the function must be the top level code. So simply we will printf scripts, and we will return. So we will do printf, otherwise we will do printf fn. That will help us print the objects that exist on stack in the debugging mode. So function name Charles. That's it. So let's build our project. Make all. So closing. Okay, you need okay, you try 3, 4. Closing. Okay. Compile. Function and function. Okay, next error. So let's clear that and make all. Okay, and compiler disassemble the instruction. No, it's disassemble. Locals count. So let's go to init compiler and here locals count. Okay. The line gets correct. Okay. So we will go to vm object.h and I will add here include shank.h and we solved the problem. So let's clear that. Okay, object function. Then vm h object function. So good. Vm objects.h. Okay, I need to remove one parenthesis here. So that's good. So let's come back and recompile our project. So we'll go to vm.c and we'll remove that. So let's clear that. Okay, we have everything right. So let's see what we have in our sample. So let's make a simple one. So I will do var a equal to print a and we will see the check here. So let's execute that. Oops. And So as you see, guys, we have the script, the bytecode of the script. Bytecode of the script. So we have, let's print the sample to see the code. We have a declaration, and we get that variable, and we print it. So as you see on the stack, we have a object script chunk. We load it to the stack, and that's what we implement is the call frames. As you see in the whiteboard, we have that frame. So in another session, you will see frame 2, frame 3, because we will implement the function calls and declaration of functions. So after we finish parsing that, we return null and return, because the top level code is just a function and it returns nothing. So we return null and we halt the machine. So I will do a simple I will update that, because I will show you a later bug. We will fix that right after that, after executing. So what I need to do is to make a scope, and I will declare a variable called 2, and I will print that variable. So this local variable is the 0 local variable. So what will happen, you will see. Let's execute our interpreter on that. So as you see, I have opcounts 2, so we load 2. So when we need to get the local variable 0, it read the object function, and that's its false, because the issue with our previous implementation of scoping, we start from we have a local variable 0, and we start 0, 1, 2, and so on. In our case, the 0 is occupied by the function that is in call. So this case is occupied by the script function. So what I need to do is to start from that location +1. So what I need to do is to go to our compiler and reserve, at every time I will reserve the first place for the function, for the object function. So what I need to do is to go to our compiler.c and fix that. So we'll go to compiler.c, and in the function init compiler, right after I will read the locals variable, compiler local count ++. So I will read the first element is the 0 location, the first local count. I will reserve it for the name of the function, or for the object function. So I update the local count by 1. It will start at each time. It will start from the location of the function +1. So I will reserve that for the callee function. So what I need to do is to do local name start, and I will pass it a empty string, and for the length, name length is 0, and also for scope path it's 0. So let's come back and recompile the project and clean, make all. Okay, then compiler, let's see. that and let's execute it. So as you see, we fixed the problem. Every local variables, it will start from 1 and so on. The 0 is reserved for the function that is in call. So guys, see you in another session, and we will treat function declaration and function call and so on. So right now guys, we implement the call frames, and in other session we will treat function declaration and function call. So in this session we did a major update on our interpreter just to support the call frame, because we will implement functions. So see you guys in another session.